So, practicals. Producing cyclohexene from cyclohexanol. Stage 1, and before I go through this practical is probably one of the hardest in year 1. So don't be like overwhelmed with the amount of content I'm going to go through just for this one practical. Just remember you can go through it once a week and you'll eventually know it all off by heart. So you've got 3 stages. Stage 1, distillation from producing cyclohexene from cyclohexanol. You want to add concentrated H2SO4 and H3PO4 to a round bottom flask containing the cyclohexanol. Because we're trying to produce the cyclohexene, we don't have it. So you want to add concentrated H2SO4 and H3PO4 to a round bottom flask containing cyclohexanol. You want to mix the solution. How are we going to mix the solution? By swirling the flask. And then we want to add 2 to 3 carborundum boiling chips. And the reason we first mix the solution by swirling the flask and then add 2 to 3 carborundum boiling chips is because these carborundum boiling chips make the mixture boil more calmly. Because think about it, you don't want it to be vigorous bubbling, vigorous boiling. You want it to be a calm reaction, so you're not really intimidated of the idea that you might get hurt or something like that. So yeah, you add these boiling chips to make the mixture boil more calmly. Then we want to gently heat the mixture to the boiling point of cyclohexene, which is 83 degrees Celsius. So we're going to gently heat the mixture to boiling point of cyclohexene. How are we going to do this? We're going to use a water bath / electric heater, one or the other. The reason I included both is because in the exam it could be like showing you stages. Sometimes they show stages, and it could be like state another piece of equipment that could be used to gently heat the mixture to boiling point of cyclohexene, and they've already included water bath. Well, the other one is electric heater. And what happens is, once we gently heat the mixture to boiling point of cyclohexene using a water bath / electric heater, is that the chemicals with boiling points higher than 83 degrees Celsius will evaporate, and when they evaporate, a warm gas will rise out of the flask. So chemicals boiling point higher than 83 degrees Celsius will evaporate. A warm gas will rise out of the flask and into the condenser. And then we can collect the product in a cooled flask. Stage 2, separation. Now we've got the product in the cool flask. However, the product collected after distillation will still contain impurities. So we're going to transfer product to a separating funnel. And what we're going to do in the separating funnel is, once we transfer the product to separating funnel, we're going to add water to dissolve water soluble impurities. So we're going to get rid of some impurities, water soluble impurities. Then we want to allow mixture to settle into layers, and we want to drain the aqueous lower layer, as this creates an aqueous solution. So we want to drain the aqueous lower layer, as this creates an aqueous solution, leaving the impure cyclohexene. Stage 3, purification. We want to drain the cyclohexene into a round bottom flask, because it's still going to contain small amount of impurities. Drain cyclohexene into a round bottom flask. We want to add anhydrous CaCl2, calcium chloride, a drying agent, insoluble drying agent, and we want to stopper the flask. Then we want to let the mixture dry with occasional swirling, and then distill mixture one last time, so as cyclohexene still contains impurities.